Okay, here we are in this regard, we are doing image classifications using keras and applications, and we are using vgg16 applications that want the completion of the image large scale visual recognition challenge. And this have many models, but we are just trying to figure out how this model works and how to tune its parameters for transfer learning object. First of all, there are 8 steps for building any keras model, and those steps are: the first step is importing the closest libraries, and here for sure we are using TensorFlow because keras is derived from TensorFlow libraries. So we are calling TensorFlow and the aim of calling keras. And then from keras.image .preprocessing.image we need to load our image to test the model and how is it working. And also we need to import the image to array to convert our image to a numpy array of pixels to be understood by the model. And then we are importing the vgg16 model, and then we are using only two functions here: preprocess input and decode predictions, and we'll know later what those functions are about. So the second step is loading the data and loading our image here. We just uploading this image, okay, .png here, and after that we are just only copying the path of it and paste it here over here. Click yameen over the input, copy file path and paste it over here. So we are now we have loaded our image, and then the third step is pre-processing data or pre-processing our image here. We need to convert the image to an numpy array of pixels. So we use image equal image to array of image, and then we need to reshape the image, and it has 4 parameters. The first parameter is the number of samples we are going to achieve. So here we are only changing the shape of first sample, or one sample, only one image. So we'll choose it one here, and image dot shape of 0, and this is array of 0 and 1 and 2 respectively. The image dot shape of 0 is considering the rows, and of 1 for the columns of pixels, and third one for the channels. And we have here 3 RGB channels, so we have 3 channels here. And if it is a grayscale, then we use here 1. Okay, and then we need the image pixel need to be prepared in the same way of the ImageNet training data was prepared by this paper. So we just write this line of code: image equal pre-process of input of image to prepare the input image to enter for the model. And here we are building the model in the fourth step, and this is our model vgg16. And I have to take care that this model will be downloaded for the first time, and it is around 582 megabytes. So and the number of parameters is 138 million training parameters. And if we need to plot our model to see the convolution layers, uh, we can write this code, but we are not, we don't need it so much, just to understand. After that, doing the protection to the protection of the variety of the image, belong which object which has been stored. We have thousand. This image in scale from the first is challenging. This challenge has 1000 image, and we need to classify them. So it is 1000 image, 1000 label, or 1000 output. Okay, so we wrote down this to protect our image belongs to which one of the 1000 object types defined by this paper. And then we are going to decode the predictions. As we know from MANIST dataset or from Fashion MANIST, the output is categorized from 0 to 9, for example, and 0 and 1 and 2 is meaning of the opposite or the corresponding input image. And after that, we need to retrieve the highest probability from this image, and then printing the classification. And if we run this code, it will write it right now. This is a tiger cat. So we have predicted this is a tiger cat, and here we just need to plot or showing our image. Thanks.